Hi, and welcome to this beginner's guide to compression. Compression is one of the most difficult techniques to master when you first start sound engineering, yet also one of the most important. The original and fundamental purpose of a compressor is as an automatic volume controller, riding the volume level down whenever the signal gets too loud, and back up when the level drops again, and doing so more accurately and consistently than you could achieve by manually riding a fader. This instance of Pro C2 is processing my voiceover, as you may have already realised. And we can see the red gain reduction line dipping down lower for louder syllables, and riding back up for quieter ones, evening out the volume level of my speech to make it more consistent and easier to mix with the background music. I also have another instance of Pro C2 processing the background music, but this time I've switched the level detection part, known as the sidechain, to key from the voiceover channel instead of the music channel, so the music gets turned down whenever I speak, then rides back up again when I stop. So far this all seems simple and straightforward enough, but there's obviously more to the story. Hardware compressors exist in many different flavours and varieties, with some vintage models acquiring legendary status and price tags to match. While Pro C2 has many parameters to tweak, plus a choice of different compression styles, which all behave in different ways. It turns out, when you look into the details, automatically controlling the volume is not such a simple thing after all. Automatic volume controllers can have a profound effect on the character of the signal they're processing. Sometimes these side effects are undesirable and we need to tune them out. But sometimes we can exploit them to make a better mix. These positive effects of compression have helped to define the sound of modern music. Let's try a little experiment. I'll load up the project for this mix we're listening to now, in which I've used only Pro C2 for all compression duties. And I'll bypass all instances so we can listen to the mix with no compression at all. Notice how the front-to-back depth of the mix collapses with the compression turned off. The vocal leaps too far forward in some sections, while disappearing into the background in others. The guitars and keys lose their consistent placement and start to wander backwards and forwards in the mix. And the drums have lost much of their power and impact. So let's take a look at the vocal and the most fundamental parameters, the threshold and ratio. I've started with the default settings in Pro C2, but for the sake of this demonstration I'm going to first turn off auto gain and slide the knee setting down to 0. And then I'll turn the ratio all the way up. When I adjust the threshold, we see the corner on the graph above, known as the knee, moves up and down accordingly. The threshold denotes the level at which compression kicks in, so if I set this higher than the loudest peaks in the audio, no compression will take place. Let's pull the threshold down to start catching the loudest parts of the vocal. And now we see the red gain reduction on the graph at the top and the meters to the right, to show how the volume is being turned down for those sections. We're now catching and controlling the bits that are too loud, but the quiet parts are still disappearing. So let's bring the threshold down further, so we're also compressing medium level parts. And now the vocal is consistently too quiet all the time. So let's turn up the gain knob to the right to compensate. This is literally just a volume control, so I could achieve the same effect by turning up the channel fader instead. But adding the makeup gain within the compressor is much better, as you can then toggle bypass without causing a big overall volume jump. The vocal now has a much more consistent level. A lead vocal like this can be placed more solidly and consistently at the front of a mix. But equally, a backing vocal part might sit more unobtrusively in the middle ground or the background. So, while the threshold affects both how much compression is applied and when it is applied, the ratio control to the right only controls how much. If I turn this all the way down, we get a ratio of 1:1, which means no compression at all. The graph above shows input levels on the x-axis and output levels on the y-axis. So a diagonal line like this means input and output are always exactly the same. If I turn the ratio back up to maximum, the output levels stop dead at the threshold. So no matter how much louder the input gets, the output won't rise above this level. Most of the time we'll want to be somewhere in between. Gentle ratio settings of 2:1 or lower can be useful for full mixes or subgroups of instruments, while a setting of around 4:1 is a good starting point when compressing individual parts within a mix. But don't be afraid to go higher if needed, particularly with vocal parts, which often need a lot of dynamic control. Of course, the harder you hit the compression, the more chance there is that you'll start to hear the artifacts that I referred to earlier. This isn't always a bad thing, but if you need a high ratio and you don't want to hear the compressor working, try turning up the knee parameter to soften the corner of the transfer curve. With higher, gentler knee settings, the compression starts to occur progressively below the threshold, instead of suddenly kicking in all at once. And this can be much more transparent. Alternatively, you could switch to the vocal compression style, which is specifically designed to keep a lead vocal up front and present in a mix. This style has preset ratio and knee parameters, and the knobs are grayed out so you can't adjust them. But the attack and release controls are still available. The attack determines how quickly the gain is turned down when the signal level is rising above the threshold, while the release controls how quickly the gain rides back up again when the levels start to fall back. A fast attack will catch and control the hard consonants of a vocal part, which might help to stop them sounding too aggressive. While a slower attack will allow more of those consonants to squeeze past, which might make the vocal sound more upfront and intimate. A fast release time will mean a higher average signal level, and a vocal part more aggressively pinned to the front of the mix. But it might cause unnatural pumping and make breath sounds too prominent, in which case a slower release might sound more natural. These controls are calibrated in milliseconds, as is conventional. But don't be fooled into taking these numbers too literally. There's no agreed convention on how to define attack and release times. And anyway, all of Pro C2's compression styles are program dependent in different ways, which means they all react differently depending on the signal you're processing. Attack and release parameters must therefore be set by ear, which means you need to train your ears to be aware of the differences they can make to the sound. I'm going to look into this in more detail in part 2. But meanwhile, don't be afraid to abuse your compressors and really pile on the gain reduction. The harder you hit your signals, the easier it will be to hear the differences when you tweak. And then you'll start to notice those differences when they're more subtle and subliminal. That's all for now. Thanks for watching.